America, a nation with an extraordinary amount of daring-do, a country where genius has been nurtured and blossomed. Once, American eyes gazed across the mighty Atlantic, saw the immense, fast British and European ocean liners that roared across the ocean on a daily basis, and American minds thought, hey, we can do that. America had been the centre of steam-powered travel as a destination, and then a pioneering American company, the Collins Line, had come to compete directly with European rivals. But that line was marred by disaster and tragedy, and the United States wouldn't seriously try for the transatlantic speed record again. But then, nearly 100 years later, things suddenly changed. This is the fastest big passenger ship ever built, the culmination of decades of hard lessons and battle-tested wartime design. She didn't come to exist in a vacuum. In every part of her incredible design is a fascinating story, and 6 great American ships had played a crucial role in shaping her development. From the incredible engines based on the power plant of some of World War II's fastest destroyers, the streamlining and the fire safety standards pioneered by the finest ocean liner of the late 1930s, the lessons of metallurgy and construction efficiency in her hull taken from the incredible production run of the Liberty ships, the elegant interiors brought into being by a pioneering design team that had honed their skills on one of the most elegant classes of passenger ships, and the stringent, obsessive eye for safety that had saved an ocean liner from sinking. All of these elements came together to create a legend, and it was down to a team of brilliant, pioneering American men and women, and the obsessive mind of one of American engineering's greatest sons. Ladies and gentlemen, I'm your friend Mike Brady from Ocean Liner Designs, and this is the story of how 6 great American ships culminated in the development of the SS United States. To understand the brilliance of the SS United States, we need to look at the figures. She was nearly 1,000 feet long, weighing nearly 50,000 tons, but she could move as fast as a family car going down the highway at 44 miles per hour. She could carry nearly 2,000 passengers in comfort over one of the wildest, vastest oceans on our planet. Her construction was nothing short of a triumph, but in her very DNA were all the lessons that had been learnt from a series of impressive ships that had come before her. But before we get into that, first, let me introduce you to somebody. This is William Francis Gibbs, now thought of as America's greatest naval architect and an obsessive genius. If you'd known him back in college, though, you would have called him a nerd. While he was studying law at Harvard, Gibbs spent most of his time outside of classes in his dormitory studying British battleship plans instead. Born in Philadelphia, the 8-year-old Gibbs had experienced the heart-stopping excitement of a ship launch when he saw the liner SS St. Louis slide down the ways back in 1894, and it had made a lasting impact. Because of his passion for ships, he was determined to make it his bread and butter instead of law, and he taught himself everything he could learn about science and engineering in a self-imposed study regime. In the early 1900s and 1910s, he was drawing up plans for a big, 4-funneled American ocean liner that never came to be. But soon enough, he teamed up with his brother, Frederick, to create their own naval architecture firm, Gibbs Brothers Incorporated. Their first contract was a doozy. They won the unenviable job of reconditioning the old German-built SS Leviathan after she'd been taken over by the United States from Germany as war reparations. The ship needed to be completely overhauled, and a simple refresh just wouldn't cut it. But Gibbs needed plans, and there was a problem. The original German builders were holding them ransom and demanded $15 million in today's money for them. It was an outrageous sum, but the Gibbs brothers got creative. They recruited a small army of men to measure every inch of the German ship to draw up a set of plans from scratch. The task was staggering, and Gibbs himself later said, "There was nothing to go by but the ship herself. We knew nothing whatever about her. We didn't even know where her centre of gravity was." It took a full year for Gibbs and his team to draft a monumental set of specifications 1,024 pages long. 13 pages had been dedicated to clock face design alone. The overhaul went ahead, and the Gibbs brothers, in conjunction with the Newport News Shipbuilding Company, had transformed the old Leviathan into what was essentially a different ship. It was a massive coup, and it sent the Gibbs brothers on a path that would see them design and build some of history's greatest ships. 25 years later, with an unbelievable record behind them, it was only natural that the Gibbs firm was chosen as the one to head up construction of what had to be the fastest, safest ship afloat. The specifications called for something that might have seemed impossible to a lesser brain. As fast as a car, but as big as a town. As comfortable as a hotel, but as safe and secure as a bank. Gibbs turned to the drawing board and he cast his mind back over his career. One of the early important lessons had always been that safety comes first. And in 1927, it had been proven the hard way. Back in the 1920s, the Leviathan job had given the Gibbs brothers an impressive reputation. So when the Matson Line, originally a freight service operating on the US West Coast, wanted to grow its selection of big passenger ships, the Gibbs brothers were an obvious choice. The first of these new proposed Matson liners would be the very first ship that William Francis Gibbs would design from the ground up to actually be built. He did this with what was then an unusually keen attention to detail, which often bordered on the obsessive and drove his colleagues and business partners nearly mad. But as it would happen, this would go on to save the lives of hundreds. The new ship would be named Malolo, after a type of Hawaiian flying fish, and Gibbs' design called for an elegant, two-funnelled liner about 580 feet long, 17,000-odd gross registered tons, with a capacity for some 620 passengers. When construction began in 1925, she was the largest ship yet built in the United States. Of her design, William Francis said, "She will be the finest liner of her type ever built. It's our intention to incorporate every modern idea that will pass the stern scrutiny of practicability." He wasn't kidding. The ship was an absolute stunner, with elegant lines and a beautiful profile, boasting modern interiors, a hairdresser's and barber, lounges and a high-tech gym. But building her had not been a picnic. In 1926, just as she was nearing completion, a fire had started that gutted some of the finished interiors, and they had to be redone. That wasn't the only issue, though. Gibbs' obsessive eye for safety and detail resulted in $4 million of unanticipated costs, thanks to what he deemed as substandard materials or defects, but which would probably have flown under the radar for any other construction project at the time. It drove the ship's builders, William Cramp and Sons, into bankruptcy, just as the Malolo was completed. But despite all this, she was delivered and ready for sea trials in May 1927, which would see the Malolo put through her paces, her engines worked up to full speed for the very first time, and her turning circle and stopping distance tested to regulations. For the event, Gibbs, his brother, and their business partner, the US Admiral David Taylor, went aboard to observe. But conditions soon began to deteriorate and a dense fog set in. The trials would have to be postponed, another small frustrating inconvenience to the ship's already bumpy construction. She steamed slowly back, engulfed in a foggy blanket. Gibbs and his brothers had stayed on the bridge and they must have been a little disappointed, but then, suddenly out of the fog on Malolo's port side, there appeared a large, black mass. It was a ship's bow and it was barreling right towards them. The Gibbs brothers could only watch in horror as a Norwegian freighter cut through the water and drove her bow straight into the Malolo's side with a horrifying crash. The Atlantic Ocean began to pour in uncontrollably. The freighter's bow had plunged straight into the boiler rooms, creating a hole 2 feet wide and 15 feet tall at the bulkhead that separated both of the boiler rooms. The ship sagged under the weight of water, and Gibbs himself walked up to the control switch for the watertight doors and threw the alarm. Bells began ringing inside the ship, but there was a problem. With the boiler rooms flooding rapidly, water had doused the furnaces, and the steam supply had begun to die out. Fortunately, the emergency generators came on, and dim emergency lights lit the hallways and the bridge. Admiral Taylor thought the Malolo was doomed. He said he had never before seen a ship be rammed square amidships and still remain afloat. Opening the boiler rooms up to the ocean like that is usually a death sentence for a ship, but Malolo was different. The Gibbs brothers' obsession with safety at sea had seen them install automatic watertight doors on all of Malolo's 12 watertight compartments, and with electricity enough to operate them, they could close. That and, unlike earlier ships like Titanic, Malolo's watertight bulkheads rose up as high as the ship's superstructure, with the watertight doors in every opening. The water just had no way to flow back through the ship, and the critical bulkhead that separated the flooded boiler rooms and the unflooded engine room held firm against thousands of tons of water. Malolo stopped sinking, and incredibly, the ship was safe. She had taken on between 6,000 and 7,000 tons of water, the weight of nearly 5 entire destroyers. Any other ship would have, and probably should have, sunk, but Malolo stayed afloat with less than a 5-degree list to port and just 6 feet deeper in the water. For the Gibbs team, this was a triumph. Their ship had comfortably survived what would normally be a fatal situation. Malolo anchored off Staten Island, and even the director of her bankrupt builders had to admit that, quote, "I doubt the hole in the Lusitania was as large as this one we have. We are in New York Harbor." That speaks for itself. If any other design team had designed the Malolo, the ship's bulkheads and safety features would have just complied with the regulations of the day instead of exceeding them, and she probably would have sunk after that collision. For Gibbs, his extreme eye for detail and that obsession over safety measures was vindicated. He later said, "That collision gave us a status no one could argue with. You have to regard yourself as a trustee of the public when you build a ship. The public just doesn't give a damn about safety, so I say, if I'm going to do ships, I'll do them to suit me. If a fellow doesn't want a ship properly divided, he can go somewhere else." This was a prickly mentality that Gibbs would carry all of his professional life. Malolo was repaired and finally completed her maiden voyage in November 1927. She became an absolute favourite on the San Francisco to Hawaii route and spent many, many happy days at sea, paving the way for a string of fine semi-sister ships, the Lurline, Mariposa, and Monterey. Years later, looking over his plans for the new United States, Gibbs took these safety standards to the next level. His new ship would be fitted with the very latest in safety equipment, with gyro compasses and radar to help detect threats in the fog. But crucially, her watertight bulkheads, just like Malolo's, would rear up the full height of the ship's hull, an unprecedented 40 feet above the waterline, creating 20 compartments. Her engine rooms were split between 2 large compartments too, a double bottom that rose higher up the ship's side than any other liners did, but crucially she was fitted with a dedicated damage control room filled with controls for fire alarms, smoke indicator panels, and the watertight door switches. With a strong, safe platform, attention could turn to the ship's shape. A lean, long silhouette would help make her the fastest ship in the world. Gibbs' mind was cast back to the late 1930s when, just before the war, he had been designing a whole new breed of ocean liner, and he had made one small mistake that he did not want to make again. By the mid-1930s, the Depression was in full swing, and America was down and out. It showed in the state of the country's merchant marine. The nation's flagship was still, after all this time, the old Leviathan. By then unpopular and aging, sailing just half full with passengers. President Franklin D. Roosevelt stepped in. He decided to introduce the New Deal, a public deficit spending program that would revive the country's economy. Part of the plan involved creating an agency whose sole purpose would be the revival of the US merchant marine, MARCOM, or the United States Maritime Commission. The US federal government had grand visions in mind, and they were eager to get started. Under MARCOM, plans were made to bring an entire new era of shipbuilding to the United States. Their opening shot would be a big one. America would design and build a new breed of transatlantic ocean liner. To design this new class of vessel, a brilliant mind would need to be recruited, and Gibbs, fresh off the back of successes like those he'd had with Malolo and the Matson Line, was commissioned to engineer this new American flagship. He needed to make sure that it would be constructed in a way that would truly put the United States on the shipbuilding map once and for all. Gibbs set to work designing this new American ocean liner, and he was determined that she would represent the very best of all his home nation had to offer. She was named, appropriately, SS America, 772 feet long with a warship-like subdivision in the hull and having capacity to carry over 1,200 passengers. Crucially, she would look like something from the future. This was the absolute height of Art Deco and streamlining modern. The new ship had a profile for a whole new age, sleek and modern. Gone was the boxy superstructure and flat-fronted bridges of old. In their place was a lovely, rounded, streamlined silhouette inspired by that age, rounded to the extreme like the front of the Zephyr locomotive. Her funnels were impressively low, but a surprising amount of planning has to go into the design of a ship's funnels. If they're too short, then smoke, soot and ash can fall freely or drift into passenger spaces at the back of the ship, making the experience extremely uncomfortable. In the early days, steamships had huge, tall funnels about the height of a 5 or 6 story building that, angled backwards, just relied on their sheer height to draw out tons of coal smoke and soot from the boilers and spew it out well clear of the ship. In the SS America's case, tall funnels couldn't cut it. The ship was meant to be streamlined and modern, so Gibbs and his team instead invested in an innovative form of funnel design to use aerodynamics to clear smoke over the back of the ship. The funnels featured fins designed to create an updraft of wind while they were moving, blasting smoke as it exited the funnel aft and harmlessly past the ship. They had tried it before, but in America they thought they had perfected it. SS America was completed for her trials in early June 1940. The ship was put through its paces and all seemed well, except for one thing. The funnels just weren't high enough. The oil smoke dropped soot and grime on the ship's aft passenger decks because the airflow just wasn't enough to clear it over her stern. It was an embarrassing oversight, and before it could be delivered, Gibbs and the builders had to fix it. The system worked to some extent, but in the end the funnels were just too low. They only needed to be raised by just 15 feet, and then they worked fine after that. It had been a valuable lesson that showed Gibbs and his team that new forms of testing these designs would be needed. The wind tunnel, previously reserved for aircraft, was brought in to help design and refine the funnels for the new SS United States in the early 1950s. The funnels put on SS United States would use that clever design technique, including the fins, but they would also be the largest funnels ever mounted to a passenger ship, standing a staggering 65 feet tall. But as Gibbs recalled his time designing SS America, it wasn't just the streamlining and funnels on his mind. There was one other thing that terrified the Gibbs brothers above collisions and flooding: fire at sea. The 1930s and 40s had been a brutal couple of decades for ship fires. Probably the most infamous was the American liner Morro Castle, which had caught fire and spectacularly burned before beaching herself in full view of the public. As he was designing the SS America, Gibbs was adamant that no such fate would befall his creation. To do it, the amount of flammable materials in the interior construction had to be reduced. One of the solutions for this was to replace wood panels with marinite. Wooden panels on ships like Morro Castle were heavily varnished, and if a spark caught on, they went up like a bomb. Marinite was an asbestos composite, and 90% of the entire ship was made up of non-combustible materials and panels just like it. Another solution was to use upholstery fillings, pillows and mattresses, made up with fire-retardant foam latex, which had been specially developed by Dunlop Rubber. This obsession with fire safety famously carried over to the SS United States. It's said that the only wood on board was the butcher's block and the Steinway pianos. Coupled with fire stations positioned all over the ship for easy access to hydrants and a crew that was well drilled in firefighting, the result was a ship that was even less likely to burn than she was to sink. But asbestos-clad panels and efficient use of synthetic building materials was one thing. Now, it all had to be made to look pretty on the inside, something that was actually outside of Gibbs' talents. But fortunately, he had just the team to help him. A brilliant pair of women he'd worked with years before on a magnificent class of now nearly forgotten American ocean liners. Back in the late 20s, the Grace Line, like Matson, had wanted to refresh its lineup of passenger ships running from New York down to the tip of South America and then up the US West Coast. Naturally, Gibbs was the best choice, and he set to it with his usual obsession. The ships he planned were beautiful, and they sported the kind of winged funnel he would use again in the future on the SS America and United States. The first of the ships in 1932 was called SS Santa Rosa, and her real beauty was found on the inside, where magnificent public rooms were softly furnished with designs inspired by English country clubs and, in the case of the club room, the balconies of luxurious hotels in Havana. But what was truly fascinating about Santa Rosa's interiors is that they were designed almost entirely by women. This was unheard of in the 1930s, and it speaks very much to Gibbs' character. He didn't care who worked for him, so long as they took the job as seriously as he did. It meant that some class-leading female designers and engineers would work on America's newest and best passenger ships, and the contract went to Elsie Cobb Wilson Inc., and two designers, Dorothy Markwald and Anne Urquhart, who would eventually form their own firm. The company had originally focused on the interior design of buildings, but Markwald and Urquhart set eagerly to work on their new task. What they achieved on Santa Rosa must have satisfied the hard-to-impress Gibbs, because when he was tasked with designing the SS America, he turned, once again, to them. Their genius was in their ability to incorporate structural elements into the design of the room, almost completely seamlessly. On the America, Markwald worked directly with the builders at Newport News to move the support columns in the ballroom to make it more inviting and open for guests. It wasn't an easy job making these ships lush and inviting, given Gibbs' insistence on cold asbestos panelling over timber and nice flammable materials. Although the idea of women decorating ships was then quite unheard of, Markwald later said, it's not without reason. For many passengers are women, and no man could ever know as much about their comfort problems and taste reactions as another woman. You can't fault that logic. The Graceline sisters and the SS America had been lauded for their comfortable interiors and their tasteful elegance. And when it came time for Gibbs to bring America's newest flagship into being, he chose them to head up the interior design for the SS United States. It ensured that America's biggest, finest ship would have some of the finest interiors afloat. Not stuffy and heavy with decoration like ships of the 20s and 30s had been, but light, chic, and above all, modern. When United States was finished, Gibbs had led a tour of British naval architects through his creation. Their faces clouded over during the tour, he later wrote, and no wonder it made them mad. They realised they'd have to recast everything to bring their ships up to the standards of the United States. They just couldn't modify the Queen Elizabeth, a little facelift, add a few feet of length and beam. They'd have to redesign her from the keel up, and if you knew what a job that is. The passengers would be housed comfortably, but Gibbs had spent a lot of time thinking about the actual construction of the ship itself. The United States would need to be big, but strong and devastatingly fast. She'd need a light, well-built hull and a thunderously powerful set of engines to pull it off. He turned his mind back to the dark days of the Second World War and the ships he'd designed that might be able to help. By the late 1930s, the Gibbs firm had become a household name in the industry, and they'd achieved such status that they were the choice for designs, not just of passenger ship companies, but for the Navy too. Gibbs' extensive knowledge of how ships worked, remember he had originally been self-taught, meant that he was always in demand for panels and committees weighing in on how to design the next generation of warships. With the outbreak of the Second World War, it soon became clear that this, maybe more than any other conflict that had come before it, would be a war of logistics. German U-boats were sinking British ships with terrifying ease. Every ton of shipping that was lost was an invaluable and irreplaceable lifeline Britain needed to stay in the fight. But in 1940 alone, Britain lost over 3.5 million tons of shipping. It was a rate of loss they just couldn't sustain. Desperate, they turned to the US for help, and Gibbs would oversee the effort. It began with the Ocean Ship, a class of 60 big cargo vessels that would need to be made very quickly, but without compromising their strength or reliability. Now, this was no mean feat. Just how do you begin pumping out big 7,000-ton cargo ships strong enough to withstand a pounding from the North Atlantic? Well, the answer was to train an army of welders and use electric welding torches to fix the steel hull plates together instead of riveting them. Riveting had been the preferred method of shipbuilding for decades, but the war would show that welding was the future because it was faster and, crucially, stronger, but it was also easier to teach to shipyard workers. It was a hull design that Gibbs had drawn up that began to slide down slipways in California and Maine, but it was the start of something much greater. Soon, America herself was drawn into the war, and with a massive and sudden need for big cargo ships, the design that Gibbs had overseen was refined and put into mass production. It re-emerged as what history would call the Liberty Ship, a class of cargo vessels mass-produced on a scale that is actually nearly impossible to comprehend. In just 4 years, American yards would build 2,710 of them, completing them at a rate of 3 ships every 2 days. The emergency shipbuilding program would eventually construct some 6,000 vessels, many to Gibbs' design, with Gibbs himself sitting on important committees and design boards that oversaw their completion. It all meant that by the end of the war, American shipyards had some of the highest skilled welders and builders in the entire world, and Newport News Shipyard, which had led the charge, would be the yard of choice to create America's new passenger flagship. But wartime experience didn't just guide Gibbs' preference for welded steel and standardized parts. SS United States would need to be fast. It was a question of power and speed. The ship's hull was strong, long and thin. Its mere shape would help it cut through the water like a knife, but what it really needed was some raw American muscle beneath the hood, and he had just the thing for it. He turned his mind's eye back to the uneasy years leading up to the Second World War, and an intense debate Gibbs had helped settle that would actually change the course of naval warfare forever. Back in 1933, the Navy desperately needed to overhaul its fleet of aging destroyers, most of which dated back from the First World War and were tragically behind the times. Gibbs began to work on a design that centered on the steam turbine, an incredibly powerful engine that took the power of high-pressure steam, turning a rotor to drive the ship's propellers. But the steam turbine had been in use since the 1900s. Gibbs knew the system could be pushed further. He knew that the more heat and pressure that steam boilers could generate, the faster the turbines could go. It would result in a vastly more powerful ship. He began to advocate for US Navy destroyers using superheated boilers that converted the wet steam to incredibly hot, high-pressure, dry steam. The Babcock and Wilcox water tube boilers chosen for this would be able to squeeze more and more pressure out, something like 65 psi more to begin with, and they'd run considerably hotter at 700 degrees Fahrenheit or 371 degrees Celsius. Now, this was a radical coup at the time because many naval planners thought that steam that hot and pressurized was extremely dangerous for both the ship and its crew. But Gibbs wanted more. He wanted 600 psi out of the boilers, and although he had the backing of a number of Navy supporters, it sparked a long-running series of debates known as the Battle of High-Pressure, High-Temperature Steam. But as always, the gruff, insistent Gibbs got his way. The Mahan Class destroyer, introduced in 1936, was built to a Gibbs design, and it was superb. The little warships used 2 double-reduction geared turbines and those superheated boilers to crack along at an impressive 37 knots, all the while using way less fuel than the more conventional Farragut class that had come just before it, but generating about 3,200 shaft horsepower more. This was a massive success for Gibbs and the Navy, and it basically guided the design of every destroyer, cruiser, battleship, and aircraft carrier thereafter. American warships were some of the fastest and most powerful of their kind during World War II, and they could all trace their lineage of those engines back to William Francis Gibbs and his team. In fact, Gibbs and his company came to absolutely dominate the design of ships for America during the war. It's thought that about 74% of all US Navy warships from that time were built to designs or plans created by the Gibbs firm, and William Francis had oversight on committees and design teams working on everything from the Iowa-class battleships to the Fletcher-class destroyers. All of them made use of increasingly more powerful superheated boilers and turbines. So of course, when the SS United States was being planned after the war as America's speed queen, there was only one choice. Using all the lessons taken from the war years, United States boasted 8 Babcock and Wilcox boilers that could produce steam at an eye-watering 925 pounds per square inch at 975 degrees Fahrenheit. The 4 Westinghouse double-reduction gear turbines could generate a simply unbelievable amount of power, 240,000 shaft horsepower to be exact, the combined total power of 5 Mahan-class destroyers and actually significantly more than the magnificent Iowa-class battleships. The final touch was the ship's propellers. Again, Gibbs deferred to a talented female protege. These 60,000-pound beasts were designed by engineer Elaine Kaplan. She and her team tested their designs in tanks to make sure the old problem of vibration and cavitation wouldn't doom the ship that would be going so fast, and nobody knew for sure if the old established principles of propeller design would actually hold up at all. "Let me say that for my money," said Gibbs, "Mrs. Kaplan is quite the equal of any technical person that we have in this place." It was high praise and confidence from the old man, and Kaplan wouldn't let him down. Her team used principles developed on American fast battleships and fitted United States with a set of propellers using differing numbers of blades. The outboard set had 4, while the inboard set, churning through the disturbed water stream a few dozen feet behind, would use 5. It reduced interference between the sets of propellers, and it ensured metal fatigue from the sudden and hot collapse of air bubbles as the blades turned would be at a minimum. On trials, SS United States ripped through the water at 25, then 35, 38 knots, the fastest a big passenger ship had ever and would ever go. It had all come together in a glorious moment of human achievement. Here was the pinnacle of American design, the work of hundreds, thousands of pairs of hands, and the brainchild of one genius mind. William Francis Gibbs passed away in 1967, aged 81, but he left behind him an incredible body of work and an unshakable legacy. He and his team of brilliant men and women had designed and built some of the most influential and game-changing ships of the 20th century. America, the underdog, a nation which had badly lagged behind Europe and the United Kingdom for the better part of a century in shipbuilding, had surpassed them. At the centre of all of it was a man who just loved his ships. Once, when he had been working day and night for months obsessing over every tiny detail, and when the mighty SS United States was at last finished, he had laid down sprawled on the deck next to a friend. "Boy," he'd shouted, looking over the amazing thing he and his team had made, "don't we have fun."